This is part 3 of lesson 3. In it you're going to learn about the number and nature of roots. You may remember when we were doing our unit on quadratics that you could find the nature and number of roots by looking at the discriminant. But now, since our power or our degrees of our polynomials are greater than 2, the quadratic formula no longer works. So the first thing to do is to try factoring. You may not like factoring, but it is the most efficient way to find the roots. If you can't factor a polynomial, then use your calculator. Your calculator, you can look at the second trace and go to zeros and find the zeros. If you find one root, you can use synthetic division to find others. And we're going to talk about that further. You have 3 examples in your notes, and this is the first one. And I start out by looking, can I factor it? And when I try that, I'm going to try factor by grouping since there are 4 monomials. So that would give me x minus 9 plus 5x plus 5. That's not going to help me any, so I know that's not going to work. I'm going to have to go to my calculator. If I put this polynomial in my calculator, I get this on the screen. I can see that it crosses through the x-axis here and touches it here. So I know that I've got 2 roots. I also know that it crosses it exactly at -1 and at 5. Just as a side note, if you zoomed out on your calculator and looked at the screen, you would see that the graph of your function looks something like this. Notice it has that big curve in it, which is indicative of all cubic functions. And since this polynomial does have a degree that equals 3, we know it's a cubic function, and it should look like that little snake in the grass. Okay? I've already identified both of my roots, both of the places where it crosses the x-axis, so I know that there are no irrational roots and no imaginary. If you looked at the chart or the table that's on your calculator by going to second graph, you could confirm what you thought was true, that there are 2 roots and that one is -1 and one is 5. And you can do that by looking right here, where your y value equals 0 is where you're going to get those roots. So I know my x-intercepts are -1, 0, 5, 0. The way that I get my factors is looking at my graph. My multiplicity helps. I know that right here it crosses. So that means it has an odd degree. I know here it touches. So I know the multiplicity of that factor will be even. So from all that, I know that my factors are x plus 1 and x minus 5, and I know this one has to be squared. I know that my total degree, my degree of this polynomial is 3, so my degrees of my factors should add up to be that same number. So it has to be x plus 1 and x minus 5 squared. So I can write my factors over here in this column. Now, just to confirm that what I did on the last slide is true, I know that -1 is one of my roots. So if I use synthetic division to work this out, I end up with, of course, 0 as a remainder. Since we know it was a root, it should work out that way. And the factor is x squared minus 10x plus 25. I can factor this to be x minus 5, but that's really x minus 5 squared. So I know the factorization, just as I wrote on the last slide, is x plus 1 and x minus 5 squared. Now you try. Pause the video and try these two problems on your own. If you get stuck, just continue the video and you'll see me working them out. When you put this one in your calculator, you see that by looking at your graph and at your table, you can see that you've got two rational roots, -1 and 2. So I know I have two rational roots, and they are -1 and 2. I've got 4 altogether because it crosses the axis, it crosses the x-axis 4 times. I also notice that I've got two irrational roots. And I don't know exactly what those are, but I know that they're no imaginaries. Well, if I use synthetic division, I can find out what those irrational roots are. So I know that 2 is one of my factors. So using synthetic substitution, I got to this point. And then I realized I could use factor by grouping. Remember where you kind of divide it and look for your common factors. So I pulled out an x squared, factored that down to this point. So this gives me my full factorization of my polynomial. If I set each one of these factors equal to 0, I can get what my roots are. So x minus 2 equals 0, so x is 2. So I know that's confirmed right here on the graph. That's one of my roots. X plus 1 equals 0, so x equals -1. That was where it crossed right here. And then my last one, x squared minus 3 equals 0. I'm going to add 3 to both sides, so I get x squared equals 3. Take the square root, and I get x equals plus or minus the square root of 3. And this accounts for my two irrational roots. So I know that plus or minus square root 3. So my x-intercepts are 2, 0, square root 3, 0, -1, 0, and negative square root 3, 0. So my factors are x minus 2, x plus 1, and x squared minus 3. Okay, for number 3, when I put this in my calculator, because I was unable to factor it, I suspect that my graph crosses the x-axis in 3 distinct points that are easy to plot. In fact, it crosses at -3. I confirmed this in my chart. -3, -2, and 1. And I see that because this is where my y value is 0. I see that it crosses 3 times, and all 3 of those times are listed in my table. So I know that there are 3 roots. All 3 are rational. They are -3, -2, and 1. There are no irrationals, no imaginaries. The x-intercepts are -3, 0, -2, 0, 1, 0. And so I can write my factors from that. Oops. That should be a positive 1. Okay, that one was a little more straightforward. Of course, if I wrote my factorization over here, they wouldn't be listed like they are in the column. You generally write them out horizontally. And they can be in any order since multiplication is commutative. Now, please do not panic. We will work a bunch of these in class, so come ready. Have the 3 worked so that you generally know what you're doing, but we will be going over these more in class. Promise me, you will not panic.